Welcome to Programming in Modern C++. We are in week 5 and we have been discussing inheritance in C++. We are going to now talk about module 22. In module 21, in the last module, we understood the basic concept of is-a relationship in object oriented analysis and design. We talked about various kind of hierarchical relationships that is possible in terms of single inheritance, multi-level inheritance, hybrid inheritance and so on. And we introduced the basic semantics of inheritance in terms of C++. In the current module, we are going to build upon that and we are going to first take a look at the two basic semantics of inheritance, that is how to manage data members between base classes and derived classes and how to manage member functions between base classes and derived classes. And then in terms of the member function, we will discuss about what is meant by overriding. Overriding, mind you, you have been familiar with overloading. We are introducing another concept, another term, overriding. What is meant by overriding and how does that interact with overloading? So, these are the, this is the outline, as you can. So, this is what where we left in the last module, that these are for future. This is what we are going to do here, that we will see that how a derived class inherits all the data members of the base class, how does it inherit all member functions of the base class, and then how can it add its own data members. The derived class can add its own data members or add its own member functions, modify the member function behavior in from the base class and so on. So, it is called inheritance because it works much in the same way the real life inheritance, that like we regularly inherit assets and liabilities from our parents, right. And when we do that, we get everything, say we get assets and liabilities, we can add more assets to it, we may create more liabilities to that, but by normally being the child of the parent, we get everything that they leave behind or that they choose to give us. So, this is, we say this is inheriting, you become an heir to that assets and liabilities, and that is the same concept that we are trying to do here. And in this, I would like to remind you that when you inherit, you do not have a choice what you will inherit, right. You cannot disinherit, right. What it means is your parents let you inherit the assets and liabilities. Now, what I would have liked as a child, that I will inherit the assets, but I will disinherit the liability. I will say no, no, no. If my parents had a loan for 5 lakh rupees, I have not inherited that, it is not my liability to pay. No, you cannot do that. So, inheritance comes with the fact that I cannot disinherit, and the similar concept exists in the inheritance of C++ as well. But I can add assets, I may build up more liability, and I can have different behaviors of what I have inherited. So, that with that basic idea of the semantics of inheritance, let us first take a look at the data members. So, it inherits all the data members, can add data members of its own, the basic point. Now, when we do this, what happens to the layout of the object? We know that the layout of the object in a simple class is an aggregation. This is like a structure. So, data members in the order in which I have listed them, they occur in that way in the memory one after the other, and we have discussed about this in terms of simple classes. Now, here since it inherits all the data members of the base class, the derived class layout must have a complete instance of a base class. We say the base class part of the derived class, and that is a new thing that is going to happen. In addition, the layout will have the data members that the derived class is adding. Right? Of course, in terms of the layout, C++ standard does not guarantee the relative position of the base class instance and the derived class instance. That is whether first the base class will be there, then the derived class will be there, or in other ways or in some other form, that is not guaranteed. So, whatever we are presenting here is just what is commonly found. It is, you can actually write program to find out what the layout is. It is not difficult to do. You can just get addresses of different data members and you will know how they are laid out, but this is just indicative. Do not think that this is prescribed or mandated by the standard. So, to take a look at the object layout, we consider a class B, which has a private member and a public data member, and then I have class D, which is a specialization of B. So, it inherits both these data members and then it adds a new one. So, let us see what the layout would be. So, I have a base class object small b, I have a derived class object small d. So, if I look at this instance, I will see that a base class object B will have this member and this member, quite naturally, that is a simple layout. In terms of a derived class object, I will have a base class instance for it. So, this is the B part of object D. Okay. Object D is of class D, capital D, but it will have a base part which is exactly the object of class B, and then it has the additional, which is the additional data member for the derived class. And you can see that this is just for a single level inheritance. If you have multi-level inheritance, the containment will keep on growing. Right? Now, what does these access restriction tell me? It tells us that D, the object derived class object D, cannot access this data member, even though it contains it. This is a situation which did not happen before, because everything was in terms of one class. But now, I have a data member in D which is populated some way, because D directly cannot do it, because it does not have access to that. So, though it is a part, it cannot be accessed, whereas this is public. So, this can be easily accessed. Right? So, this is the basic semantics of the object layout. So, next let us move on to the member functions, right? See what the member functions can do. So, in terms of the member functions, we say that the derived class will inherit all member functions of the base class. Right? So, it can use all of them. Mind you, there is a caveat to that, which you must remember, that derived class does not inherit the constructor or the destructor, because the constructor and destructor have class specific names. The constructor of the base class will be called base, the destructor will be called tilde base. So, they are not inherited in the way that you can use them as base class function, but you must have access to them, because unless you have access to them, you will not be able to construct the base part of the derived class object. We will see more of this when we go into construction destruction. Now, there are two special properties that a derived class can override a member function it has inherited by redefining with the same signature. It does not change the same, does not change its signature, but gives a different implementation, gives a different body to it. Right? If it does not give, whatever it has inherited will work, but here it can choose and give a different signature to it, give a different implementation to it, keeping the signature same. or it can choose to overload when it redefines with the same name, but with a different signature. You know, that is the basic rule of overloading. So, it becomes yet another different function, overloaded member function, or it can add new member functions as well. Mind you, these cannot be inherited. Static member function or friend function cannot be inherited, which means that in simple terms it means that anything that can be inherited must have this pointer, right. So, it is only non-static member functions which can be inherited by this process by the derived class from the base class. So, let me with a simple example illustrate what is the difference between the override and the overload, the two terms. So, the first here is the inheritance. There is a class B, and for simplicity I have kept everything in public, right, because otherwise the derived class will not be able to use it, because we have not studied protected access yet. So, everything is public. In the base class you have two functions f and g, right. So, in the derived class you have inherited them, commented out. I have not written anything. So, if I construct two objects B and D of the respective base and derived classes, then what is the behavior I will get? If I do B dot f1, that is a simple case, you know, like we were doing. B is accessing function f with parameter 1. So, it calls the function f of B. If I call B dot g2 this function, it is B colon colon g as we had. The interesting thing is, if I do this with D object of the derived class, also these two functions will be called because they are inherited here. So, they have not been written, you do not see any function, but actually this function is available here, this function is available here. So, you get to call B colon f and B colon g by the object D of the derived class D. This is the simple inheritance mechanism of member functions. Now, how do I control this? I again have the same base class, I have not done anything. I have inherited B colon colon f, right. So, it is available. What I do is I have again written the same signature, mind you, between this and this, the signature is same. Here I did not write it, but here I have written it again. When I write it again, it means that, well, I have inherited f which takes int and returns void, but I want to give it a different definition, I want to give it a different implementation, and that is what is called overriding. It is not overloading, because the function signature is not different. What is different is one function belongs to class B, the other function belongs to class D, and the way you let the compiler know is by including an identical signature in the derived class. What I have further done is I have given another function f here, another member function f here, which takes the parameter of reference to string. Now, this is not same signature as the original f function. So, between the original f function and this, or between the overridden f function and this, the signature is different. So, this actually is a overload of the B colon colon f. So, here I have done two things together. One is I have overridden by giving the same function signature, but intending a different body which I will write, and by giving a function with the same name, but a different signature, for which again I will give a body which overloads the original member function. So, this is what I have done here. With G I have not done anything. So, G I have just inherited. F I have inherited and overridden if I have inherited and overloaded, and then finally h is a new function that I have defined only for D. It does not have a correspondent in the base class. Right. So, these are the 4 possibilities. I can inherit an override, I can inherit an overload, or I can give a new function. Right. So, these are the 4 cases available here. Again, I have 2 objects created. If I make the original call as before, naturally I will have the same function calls. There is no difference because base class I have not touched. Now, what happens if I make these 2 calls again in this context? Now, G I have not touched, right, I have just inherited. So, G will call B colon colon G, that is this function in any case. But what happens to this particular call? Earlier it was calling B colon colon F, because I had just inherited, did not do anything. Now, I have inherited and I have put it here again to override. So, when it is overridden, then it is the most recently overridden function is what will get called. So, this calls D colon colon F, that is this function, whereas this calls this function, that is overriding. So, this is the case of override, right. I hope you are getting it clear. So, just study it parallelly. Now, I have also called D colon colon F with a const cat star parameter, which can basically become a reference to string, a temporary object of string will get created, which I could not have done here because that kind of a member function did not exist. So, this is naturally this is going to call the function in D, because in B no such function exists, and this is the case of overload, because a different signature, different from what B had defined, a different signature is being used. So, by overload I will be able to call this function. Finally, H is again a simple case, H was not here. So, there is no question here, but when I do D dot H, a new function member function has been added. So, D colon colon H will be called. Right. So, I think this slide will be a very crisp summary of what happens in member function inheritance, 4 possible cases that you can have, and what is the behavior. If you keep this ready with you, handy with you all the time till it gets settled in your mind, it will be very useful. Just to remind you again, you inherit all member functions from the base class. You can keep the signature same and still put that signature in your derived class. You are overriding, you will have to give a new body. You can keep the function name same, give a different signature and give that body. You are overloading the member function, or you can add new member functions. So, this is the whole scenario of member function semantics in inheritance. So, quickly we can take a comparative look also. This is just summarizing what I have been saying. The name of the function, certainly whether you this is comparing overloading and overriding. Overloads always have the same function name, overrides also have the same function name, otherwise the context is not array. Signature is for overload, the signatures must be different. For override, the signatures must be the same. What type of function can be overloaded? We have seen global functions can be overloaded, friend functions can be overloaded, static member functions can be overloaded, non-static member functions can be overloaded, all of these can be overloaded. But overloading, as I have already mentioned, can be done for only non-static member function. You may find that I have written some terms after this which you are not familiar with, do not worry about that. We will learn about this in terms of dynamic polymorphism, and at that time I will clarify what they mean, and you will understand the extensional behavior of override in that context. Then what is the role of inheritance? Certainly function overloading has nothing to do with inheritance. It can be, for example, in these cases it works without any inheritance. Here it can work without or with inheritance, but overriding works only in the context of inheritance. Signature, I think the signature line has been repeated twice. So, you can just ignore this, we have already talked about it. I will remove it from the slide subsequently. Then we say polymorphism. We have talked about polymorphism in the context of overloading, saying when you have the same function giving you two or more different behavior, you have a multiply morphed behavior. So, which you say is polymorphism. Now, in terms of overloading, it is necessarily at compile time. In terms of overriding, it could be compile time, like the example that I have just shown is compile time. But what is interesting more is when you start having overriding in the dynamic context, which is what will happen when we talk about virtual. So, that will come in the future. Scope, obviously overloaded functions are always in the same scope, but the overriding is happening in two different scopes. So, you have a member function in the base class scope and you have a member function in the derived class scope. So, it is happening across scopes. Overloading will always happen in the same scope. The purpose is clear, to have multiple behavior for overloading by the same function name, but for overriding the main purpose is to perform a different task than what you have got, right. So, you get a behavior, but you are trying to modify that behavior. It is only applicable in that context. Naturally, constructors can be overloaded, constructors cannot be overridden. You can understand in multiple ways. One is the constructor in the context of the derived class, the constructor of the base class cannot be conceived, because constructor of the base class is the name of the base class, and so it has no role in that way. Besides, so we had already mentioned that the constructor actually is a static class, a static function, right, because it does not, when the constructor is invoked, at that time the object has not been constructed. So, this pointer does not exist. So, constructor cannot be overridden. The destructor, as we have seen, cannot be overloaded, because destructor has to be unique. It cannot be overridden also for the simple reason that the destructor of the base class and the destructor of the derived class, like constructor, have different names. Okay. And naturally, overloading can be done multiple times, but overriding can be done only once in a particular derived class. So, these are the relationship between function overloading and overriding. This is a very, very important topic. This is a very, very important behavior that will drive the way we deal with different semantics of inheritance all across, and therefore, we will you will have to be very careful to understand it, practice it, and as I said, always refer to the slide of base and derived example with 4 types of member functions in the derived class. So, to summarize, we have dealt with the first part of the semantics of inheritance in C++. We have shown how data members are inherited, and the fact that all data members, or for that matter the entire instance of a base class, is a part of the instance of the derived class, and in the object layout we do not know when they will, where they will occur. C++ standard has not specified, but it will be a part. And interestingly, it could be that there are some private members in the base class, data members in the base class, which the derived class instance will contain, but will not be able to access. And we have seen the effect of inheritance on member functions. You inherit all member functions, you can override them, keeping the signature same, giving a new body. You can overload them by giving new different signatures, or you can add new member functions. So, equipped with this, we will close this module, and we will move on to the next to explore further on the semantics. Thank you very much for your attention, and we meet in the next module.